Greetings. This is Ryan Mahoney here with Gigamon. This is the boot camp session for packet reduction on your Gigamon devices. By way of introduction, so I'm the product management director for the service provider business globally here at Gigamon. I've been doing a lot of work on 5G prior to this. I was at Verizon Wireless for 20 years, spent a good deal of time owning and operating the visibility fabric there, and as you might imagine, the ability to keep the probe costs down and keep the packets reduced was of prime importance. And so that's what we're going to be talking about today. So let me pull up the slides. All right, packet reduction techniques for service providers. So we're going to start by taking a look at this phenomenon that we call breaking the cost curve, which really is a setup as to why this is necessary at all. The second section, we will go into packet reduction techniques. We'll go into a little bit of detail. They'll still be fairly high level as to how they work. If you want any more information, more details, of course, you can always contact our sales engineering team, can go out and set up something pretty specific to you and your needs. And then lastly, we'll get into some additional optimizations, which aren't strictly packet reduction, but they complement them very well and may be of interest to you if you're considering using one of these packet reduction techniques. So let's start with breaking the cost curve. So we all know that the network demand is increasing. It's globally, it has increased year over year at highly significant rates, double-digit growth. Some of the LTE years saw between 50 and 100% growth in a single year. And we don't necessarily see the growth stopping, particularly as we go into the 5G. And so this conversation that I have on the screen here is one that I know I have heard before, and maybe you have too. It usually starts with someone either in finance or someone who is in charge of the spending, just asking very simple, basic questions on why do we keep spending more money on probes? Seems like we spend more this year than we did last year, than we did the year before. And it's all because the network is growing. And the network performance teams, rightly so, they want to see every packet so that they can guarantee performance. Similarly, the network security teams wants to see every packet so they can guarantee security. So some of the problems that we're looking to solve here is, number one, extending the life of existing tools, and at the same time reducing the cost, the year-over-year spend on some of these tools. But very, very importantly is to do it without sacrificing quality. It's easy just to shut off traffic and then say, well, you'll live with it. But it's far better if we can have some targeted, intelligent ways where we only turn off the traffic that's not really all that useful. And then that last point around budget, we like to say here at Gigamon that you don't need budget to buy Gigamon, which is to say that many of our solutions here pay for themselves in less than a year. So you have a return on investment of less than a year on most of what we do. All right, so then what does the cost curve look like? So earlier I talked about network growth, just growing year over year, and you can follow this blue line. This blue line is year over year growth. Pick any starting period. And the cost curve that we're depicting here is really to say that the cumulative spend on probes is going to grow in direct proportion to the network growth. So if your network grew by by 2 terabits this year, then you need 2 terabits of probe capacity. If it grows by 4 terabits next year, you need additional 4 terabits of probe capacity. And this continues to go until it gets really unsustainable. And you know, what we're showing here is the before and the after. So if you continue to just continue with a strategy where you probe every single packet, then this is how the cost will look. We like to propose, instead of letting that cost curve continue to go out of control, let's break it. Let's break that cost curve using Gigamon, using packet reduction techniques, again, without necessarily sacrificing quality. I know that these charts look somewhat alarming, particularly with some of these very big numbers that are being shown. I can tell you this is based on some very real charts that I have seen firsthand in my career, and it really truly is not out of the realm of possibility. Okay, so then what are packet reduction techniques? Well, so we talked about why do we want to reduce packets to probes, and it's really to control costs and extend the life of tools. So the majority of this presentation is really about what are some of those different packet reduction techniques? How can we do it to maintain quality? And the answer to that question is a little bit complicated in the following sense, is it depends a lot on what you want to do with it. What are your tooling goals? Is it more based on performance? Are you looking at performance monitoring? You're looking to create KPIs? Are you more interested in troubleshooting, performance troubleshooting, finding customer issues, customers calling with problem, you want to go back a couple of days and know what happened? Or is it more around security? So security tools tend to have some different styles of traffic and things that they look at than a performance tool would. And so we have some different techniques that are more appropriate based on what are the conditions that you are trying to solve for. And they all have some different profiles in terms of what are their what's the amount of traffic that they can reduce. Some of these are subject to how you configure them, such as sampling. You could set a sampling rate of 10% and thereby eliminate 90, or you could set a sampling rate of only 50%. It's really up to you. Some of these are a little more prescriptive, that if you turn it on, such as advanced flow slicing, if you turn it on, you're going to get 75% reduction, most likely somewhere in that neighborhood. Versus if you turn it off, it's not super configurable. We'll talk about why that's true when we get to that section. And then active visibility is one of our complementary technologies, and we'll talk about that even though there's not a specific reduction amount associated here. Okay, let's go through some of these different techniques. Oh, and a quick plug for any service providers who are interested in what we have to say, but maybe would like to see it for themselves, at least on paper. We have an ROI calculator. It's a fairly simple Excel spreadsheet where you enter in some information about your network on the left, and it calculates what would be the ROI savings for you year 1, year 2, year 3, and so forth. And this is really, looking at the total cost of Gigamon plus your probes. So not just Gigamon only. We're really looking to put together, as much as is reasonable, a view for you of your total cost of ownership with Gigamon versus without. Okay, so now let's get into some of the specific packet reduction techniques. So the first one on that list was subscriber whitelisting. And even though it says 5G here, this applies to 4G as well. So we have both 4G and 5G versions. Since I do most of my talking about 5G, I happen to have a 5G slide here at the ready. So whitelisting, it's fairly simple to understand. You as the you as the user of the Gigamon fabric would provide a list of subscribers. In the 4G world, you would provide a list of IMSIs. For 5G, the IMSI equivalent is called the SUPI, but these are effectively, it's the exact same type of data element as an IMSI is. You provide a whitelist. We can have up to, I think, 2 million IDs in a whitelist. And all the user plane traffic, you send it into the Gigamon fabric. You turn on whitelisting, and you say, I only want to see the sessions. I want to see all the subscriber sessions. I want to keep them whole, but only for the SUPIs or the IMSIs that I provide. So that's what this does. Some of the common whitelist targets would be your own engineers. So you could whitelist every single company provided mobile phone that you might have for all of your engineers. That way, any call they make, they can go and they can go in and they can see whether they're doing their own troubleshooting or drive tests or what they are. So engineers is a big one. Drive tests, both for you as well as third parties. Typically, third-party companies here in the U.S., it's RootMetrics and Nielsen are two of the big ones, where they will do third-party drive tests, and they will usually supply ahead of time what are the IMSIs that they are going to be using on the network, but they may supply that like 30 or 60 or 90 days ahead of time, and then they do the drive test, and then you get the results much later. And if you're probing every packet, those sessions would have been overwritten a long time ago in the sea of everything that's going through your network. But with whitelisting turned on, you can have just those SUPIs, just those subscribers in the whitelist, and you could even direct these maybe to a special probe that has longer term storage because it's not being overwritten, because it's dedicated just to your drive test inspection. And then the last use case here that I really like to talk about is customers calling into tech support, so they could integrate with your voice dialing system, your IVR system, or perhaps with your ticketed system. Imagine a scenario where any customer who calls in for tech support, they automatically get whitelisted for the next 30 days or some amount. We can enable that through, we have APIs that are available on our visibility fabric. So whatever system you have, you could easily integrate to Gigamon to say, to control the add and removal of those whitelist entries. All right, so that's whitelisting. Whitelisting is great for performance troubleshooting. That's the main use case that it has. Naturally, whitelisting is not so good for performance KPIs because it's a very small targeted subset of your overall traffic. For that reason, whitelisting is very commonly combined with the next technology that I'm going to show here, and that's sampling. So 5G subscriber sampling, again, this also works on 4G, and the way our Gigamon fabric is designed is that sampling and whitelisting are really paired together. They're run on the same engine, so it's really designed from the ground up for these two to work together. So sampling is fantastic for performance monitoring, for KPIs. So you can get statistically accurate KPIs with only 30% of your traffic rather than needing all 100% of your traffic. So you save a lot on your tooling costs and you still get your quality KPIs. But then what, of course, this doesn't necessarily solve so well is doing troubleshooting. So if you have a specific customer or a call that you're trying to troubleshoot and it was sampled out, then how do you do that? So this is often paired with a whitelisting strategy, so you get the best of both worlds without having to send every packet to a tool. One last note on this is we have Random sampling, which is just as you might imagine, it's it's randomly sampled. It is important to know that when we do sample, it's not sampling packets; it's sampling entire subscriber sessions. So a subscriber session, including the control and the user plane traffic, is all sent to the same probe. So we have random sampling available. We also have deterministic, which is what's depicted here. So you can do a deterministic sample where you look at the last few digits of the MZ or the SUPI. You say, I'm going to sample based on this. So what I have depicted here is effectively a 50% sample by only picking up even numbered SUPIs or even numbered MZs. And this is attractive for the majority of our customers who use sampling because, well, by its very nature, it's deterministic. You will know whether a session, if you don't see a session in your tool, you will immediately be able to answer the question, do I not see it because it wasn't on the network, or do I not see it because it was sampled out? With a deterministic algorithm like this, you'll always have the answer to that question, and it will also be consistent from location to location. So you have multiple locations, you'll know that location A and location B did it the same way. For example, if you had IMS traffic in one location and EPC traffic in another location, for the same subscriber, you will know that they will all hit that probe. And so the probe can do whatever backend correlation it needs to do because it has all those subscribers in that deterministic fashion. Okay. Moving on then, so those last two were subscriber aware functions. So it's all about reading and correlating the control and the user plane of the subscriber and taking action based on the subscriber identifier. This next one is a little different. This is also one of my favorites. It's a newer capability that we have here at Gigamon. So it's called advanced flow slicing. It works very similar in principle to a packet slice. So you probably know what a packet slice is, where you keep the header of a packet and you drop the payload. This is working in a very similar fashion, only instead of working off of a packet or slicing a packet, we're instead slicing a flow. So what is a flow in this context? Think of a Netflix movie or a YouTube video. Your tool have value in those first 10 or 20 or 30 packets in that flow, has all of the TCP handshake and setup information, information about what's the video that's going to be played. But then all of those video packets for the next 30 minutes or 2 hours or however long the video is, you have the option to drop them, or you can also do a traditional packet slice on them just based on your needs. We have found this has been very attractive for security tools because they tend to really only care about a lot of that initial setup information. It's also a really interesting use case in performance monitoring. And here's why. Most of the traffic on a mobility network these days is going to be encrypted with HTTPS or with a TLS encryption. And in those, for those types of sessions, it's very hard, very difficult for most tools to be able to do anything with those packets other than just calculate volume. What is useful in a troubleshooting type of scenario is to have the knowledge of whether or not that session was set up. So it's the condition. So one of the things that you could do, by the way, to reduce traffic to tools is to just remove all the HTTPS traffic. You could do TCP 443. It's very simple, very basic. Don't even need GigaSmart to do it. We can enable that. So that is an option that you can do. But this is a little more intelligent, because what that one doesn't do is, for any subscribers who have only HTTPS sessions, all of their user plane does not get sent to the probe, and therefore the tool cannot know whether or not whether or not the user plane session was set up. And that can be an important piece of information for troubleshooting real world scenarios. So advanced flow slicing gets around that because you have those initial packets, but based on real world production deployments in very large operator networks, we've seen 75, 80% reductions by turning this on. All right, so let's move on. So that's advanced flow slicing. The next one here is application filtering. So this works off of us doing a deep packet inspection to understand what is the over-the-top application being used. For example, is it Netflix? Is it YouTube? Is it Yahoo? What's the over-the-top application being used? And then you, as the user, have the ability to configure which of these over-the-top applications that you want to filter out. What do you not want to send to the probe? So, for instance, in a security tool situation, you may say, I trust all traffic that comes from YouTube from a security standpoint, and therefore I don't need to send any of it to my security tool. I care about all of the unknown stuff, all of the things with malformed headers and all the things that are not commonly used applications. So this enables you to do that. We partner with a third party who does internet cataloging, and so they provide us signatures of how to detect different types of applications. I think we have over 3,000 different applications in our engine that can be detected. So that is application filtering. The reduction amount that you will see from this depends entirely on what are the applications that you want to filter out. Next we have deduplication. So this is one that's been around for a while. It's fairly useful in a service provider network. It's the use case, the setup here is if you are tapping all of your network elements, such as an MME and the SGW, then the S11 message that goes between the MME and the SGW will be captured in two spots. So you'll have the S11 leaving the MME and the S11 entering the SGW. Almost every time, the only thing that's different about these two packets is the VLAN. Everything else is the same about it. Sometimes even the VLAN is the same, depending on your network design. So our deduplication engine works by giving you the ability to ignore the VLAN, send all the traffic from all the taps into the visibility fabric, and it will intelligently know that I have two S11 packets that are the same. I am only going to send one of them onto the tool. So you have up to 50% reduction. You wouldn't really ever see more than that. But this is very useful for messages, particularly within the same location. You can do dedupe, by the way, if you're crossing locations. Say if you have the MME to a DRA that's in a different location, you could potentially do a dedupe there. You do have to do some backhaul to make that happen, so it's not as attractive there. But certainly within a given location, and if you think about something like S5, it can be very very cost saving when it comes to the volume of packets. Okay, and then the last in this section that I have of these packet reduction techniques. So we've just gone over 5 of them. I did have a 6th one up there, which was the protocol filtering. Don't have a specific slide for that, but I did mention that earlier, such as if you just wanted to remove the HTTPS traffic, you can do that. That's fairly straightforward to do. This is a case study here that's using our advanced flow slicing. So this is a tier 1 mobile operator, lots and lots of traffic, and they wanted to use advanced flow slicing to send traffic to their tool for security and for performance. And this is showing you just very in a very basic manner. If you had 100 gigs of traffic that came in, there was 25 gigs that left. And even though the traffic was the HTTPS, there's enough value in there, including the client hello, server hello certificate, server hello done, client key exchange, change cipher spec, and the finish. So all of those types of packets are typically found within the first 20 or 30. Again, you can configure that however you like to have it on your network. But this customer used a combination of advanced flow slicing with another technology we have called enhanced load balancing. It's just a way to load balance traffic based on the inner source IP of the GTP tunnel. So the load balancing by itself, of course, is not performing the reduction. The flow slicing is performing the reduction, and then the load balancing is directing it to the tools that they have, which are based on an x86 platform probe. Okay, so that is those are the packet reductions. So there's a few complementary optimizations that I want to talk about here. This first one is something we call active visibility. It's a technology we've had for a while. By itself, it doesn't reduce anything. This is more of something that you would use in conjunction with one of the other packet reduction techniques. As it says here, it's a booster. So what this allows you to do is it allows you to turn your reduction on or off based upon triggers. And even in the case of something like sampling, it doesn't have to be an on and off. It could be change the sampling rate. You go from 50% sample down to 30 or up to 80 or to 100 or whatever, or 0, whatever you want it to do. And so what are these triggers? So you could have a time of day trigger, such as during the maintenance window, when you want to make sure you see every packet, you can turn off your packet reduction and send everything to your probes. And when you get into busy hour, you can turn the packet reduction on so that you don't have to size your probes for this extreme peak traffic. You just size it for more of an average traffic throughout the day. That's one. So this time of day, we can also do it off of tool port utilization. So if you have a tool port, say you have a tool that has two 10 gig interfaces, but can really only process 16 gigs of traffic. So you could set this to say, hey, when either of those two ports goes above 8 gigs or goes above 7.5 gigs, whatever you want it to be, then take the action, launch the trigger, and turn on the packet reduction. And then when it goes down below or it's a comfortable rate, you can then turn it back on. Turn it off. So you can do that based on the utilization rate on the tool ports, or even on the tool port discard rate. So if you see non-zero discard rate, then that can be a trigger to turn on packet reduction. All right, so that's active visibility. The next one we have is RAN correlation. This is one that is it's built upon our GTP correlation engine and our 5G correlation engine, and it's the ability to apply different monitoring policies based on the RAN source. Special event monitoring is a big reason to use this. So if you're with me so far in understanding that, yeah, it's probably a good idea to consider a packet reduction technique, a packet reduction strategy, but how do I how do I take care of some special cases that I have? Well, we've got lots of different techniques. I don't have all of them here today. I do have a few of them. So this one here is RAND correlation. So if you subscribe to the notion that, well, maybe you want to do a 30% sample in the general case, but I've got this big special event or sporting event or presidential inauguration or whatever it is, and you want to make sure you've got all the packets for that whole event. Maybe you even have a dedicated probe for it. In any of those cases, we can have a different visibility policy based on the RAND source. So based on either the tracking area or based on a whitelist of cell IDs. Now in LTE, you can kind of do this today without, or with just using the eNodeB IP address. But that in the world of vRAN and CRAN, that tends to get more complicated and less distinguished, less deliberate. So this allows us to look at the actual, the RAN cell identifiers from the control plane packets for both 4G and 5G to perform this this correlation. And then and then traffic for, say, this list of cells, you can then do whatever you need to do with it. You can send it to a special probe, or you can just make sure that you've got all packets going to your regular probe. Okay, so that's RAN correlation. And I think the last one that I have here is network slice correlation. Now this one is specific to 5G. It's not a 4G option, of course. So network slice is a 5G technology that allows you to create different slices of your network, all the way from the radio through the core, and even in some cases an enterprise customer network. They're all on a single network slice with their own dedicated resources and policies. This capability of this network slice correlation is predicated on the assumption that different network slices will have different value and therefore will have different visibility needs. You could, for example, have a very high value network slice for which you want to see 100% of the packets 100% of the time. And you may have a lower value network slice where you only want to see metadata, or you only want to see certain applications. And then you could have a general case network slice where you do a sampling and load balancing combination. So sky's the limit on using your imagination on how to put these together, but you can use network slice correlation along with RAN correlation together. And that is the end of the presentation. I'd be happy to take questions through the chat, and we'll answer them as quickly as we can. Thank you very much.